I'm going to talk about the aromatic compounds. The adjective aromatic is used by organic chemistry in the order of different ways that is normally applied. It was in the origin that the observation that certain natural substances such as cinnamon bark, wintergreen leaves, and vanilla beans contain ferment compounds having those compounds both unstandard properties. To finding the if an aromatic compound name is find the lowest continuous change in the of carbon atoms. Then name that longest chain with the appropriate alkane name. Then find the substitute and name of each of them with an appropriate group name. Number the carbons in the chain that has the lowest number given in the group nearest one to the end of the chain, and list the group in alphabetical order in front of the longest chain name. Then precede each group name with a prefix indicating how many of them are present in the molecule. One example of naming these aromatic substances are colorants. There is an example of an halogen attached to a benzene ring. The name is like self-obvious. Another example is the methyl blends that is from nitro groups NaNO2 and is attached to the benzene ring. And the simplified formula is C6H5NO2. Methyl Venus. Another obvious name. The Venus ring has a methyl group attached. The simplified formula is C6H3CH3. For giving a chemical formula to an aromatic substance, we need to calculate the degrees of the unsaturation pH bonds rings that often implies in the presence of an aromatic ring. In this IR spectrum is the given look for a giveaway spectrum such as CO OH. Then if we have the 13C spectrum, determine the number of non-equivalent carbons in your spectrum, and then for your 1H NMR spectrum, look for the before told giveaway with a chemical shift. Then look at the integration that determine the number of hydrogens associated with each set of peaks. Remember the numbers of hydrogens on the spectrum must be equal to the number of hydrogens in your molecule. After that, we'll look for at the splitting. Use the n+1 rule and write down the fragments. Remember, when there are like more than 4 peaks, it's better to say that it's a multiplet. After that, we put all the fragments together as many ways possible, leaving no unfilled balance. And at last, we use the chemical shift data to determine which functional group are next to which hydroxyl atom. Some examples of this formula are FCRBr, which a bond representation of C, a double bond, and two single bonds. Then, which is the other one, which is C with a triple bond and just one single bond, and the other one that is C with 4 single bonds.
Well, hi, I am going to explain you the UPAC and what does it do. The UPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization, not affiliated with any government. The UPAC strives to advance chemistry, in part by setting global standards for names, symbols, and units. The UPAC was formed in 1999 by scientists and academicians who recognize a need for standardization in chemistry. The predecessor of the UPAC, the International Association of Chemical Societies, met in Paris in 1911 to propose issues that need to be addressed. From the beginning, the organization has sought international cooperation between chemists. In addition to setting guidelines, the UPAC sometimes helps to resolve disputes. An example is the decision to use the name sulfur instead of both sulfur and sulfur. Okay, I am going to explain you what is an hydrocarbon and the different types of hydrocarbons. In organic chemistry, an hydrocarbon is an organic compound consisting entirely of hydrogen and carbons. Hydrocarbons from which one hydrogen atom has been removed are functional groups called hydrocarbons. Aromatic hydrocarbons, alkenes, and cycloalkenes, and alkene-based compounds are different types of hydrocarbons. The saturated hydrocarbons, most called alkanes, are the simplest of the hydrocarbon species. They are composed entirely of single bonds and are saturated with hydrogen. Unsaturated hydrocarbons have one or more double or triple bonds between carbon atoms. Cycloalkenes are hydrocarbons containing one or more carbon rings to which hydrogen atoms are attached. Aromatic hydrocarbons, also known as arenes, are hydrocarbons that have at least one aromatic ring. Hydrocarbon can be bases, liquids, waxes, or low melting solids, or polymers. Polyethylene.
What is an alkene? Hydrocarbons having no double or triple bond functional groups are classified as alkanes or cycloalkenes, depending on whether the carbon atoms of the molecule are arranged only in chains or also in rings. Although these hydrocarbons have no functional groups, they constitute the framework on which functional groups are located in our classes of compounds and provide an ideal starting point for studying and naming organic compounds. Okay, first, to start naming alkanes, it will make us easy. We have a list of prefixes from 1 to 10. Okay, the first step in naming alkanes are to find and name the longest continuous carbon chain. Then here we have 1, 2, 3 to this chain. That it's in the number 2. That it's here, this one. Then we have to number the chain consecutively, starting at the end nearest associated group. We start from the end, 1, 2, 3, and 4. After that, designate the location of each substituting group by an appropriate number and name. And then assemble the name, listing groups in alphabetical order using the full name. So we finish it with 2-methyl because we have it in the number 2 and it's only 1, and as we have it here, 1 is equal to meth. 2-methyl butane because the largest chain is of 4 carbons, 1, 2, 3, and 4. Another example to name alkanes is we have these chains, and we have to find the largest chain, and we have 1, 2, 3, 4, and 5. 1, 2, 3, 1, 2, 3, 4. So no, this one is the largest, so we circle it. And we have 1 and 2. And we have 2 to number the chain from the end. 1, 2, 3, 4, 5. The first one is in the 3, the second one is in the 4. So with 3, 4 dimethyl because we have 2 of 1, pentane because the largest chain have 5 carbons. To finish with alkanes, we're gonna learn how to draw the structure of formula. Okay, here we have 2, 3 dimethyl butane. Butane means 4, so we're gonna write. We have butane at the end. It means the longest carbon chain has 4 carbons, 1, 2, 3, and 4. Then we're going to add the groups at the proper positions. We have the 2, 1, 2, and 3. Right, so carbon, we got H3, H3. After we finish that, we're gonna write the hydrogens that are missing. Okay, here we have 1, so it's 3. 1, 2, 3, so just the H. 1, 2, 3, just the H. And here. And that's how we do it.
Well, I will talk about what is an alkene. An alkene is an unsaturated hydrocarbon that contains at least one carbon-carbon double bond. Alkene, olefin, and olefine are used often interchangeably. Acyclic alkenes with only one double bond and no other functional group, known as monoenes, form a homogeneous series of hydrocarbons with the general formula, that is CnH2n. Alkenes have 2 hydrogen atoms less than the corresponding alkene, with the same number of carbon atoms. The simplest alkene, ethylene C2H4, which has the International Union of Pure and Applied Chemists, produced on the largest scale industrially. Aromatic compounds are often drawn as cyclic alkenes, but their structure and properties are different and they are not considered to be alkenes.
Good afternoon, I am Ruben and I will show you how to name the alkynes with 3 examples. The first one is the easiest one, but first of all, what is an alkyne? An alkyne is an hydrocarbon which has triple bonds between the carbon atoms. And the first step is to count for example, 1, 2, 3, and 4. The number 4 is butane, but it is an alkyne, so you need to add the last name YNE, which is butane. And the second step is to number each part. For example, 1, 2, 3, and 4, starting from the side where the triple bond is. In this case, it is 4, so it is the same. So the carbon atom is in the number 2. So we write 2-butane, and this is the name of this alkyne. Another important thing, this is this alkyne because most of the people, or some mistakes of the students, is that they, for example, do this, and this is wrong because the triple bond must be in an horizontal way. Okay, here we have a Dayanne, which is when you have 2 triple bonds in the chain. We must start counting from the left because there is like the triple bond, so it's 1, 2, 3, 4, 5, 6, and 7. So it must be ept. The carbons of the triple bonds are in the places 1 and 5, so it must be 1, 5, Dayanne. So to write this, it must be 1, 5, hepta, Dayanne, and that's it. Okay, in the second example, we have a substituent in the chain. So we must start counting from the side of the substituent from the left. So it is 1, 2, 3, 4, 5, 6, and 7. So it must be hept. The carbon atom of the triple bond is in the position 5, so it is 5Y and E. And the substituent is in the position 2, and it is 1, so it is 2 0. The final name should be 2 methyl 5 heptane. Okay, now we are going to draw the structural formula for the alkanes. This is very easy. For example, in here we have in the first one the propane. What you need to do is to first draw all the carbons, and at the end the carbon with the triple bond. For example, in this case we have only 3 carbons, so we are going to do this. The first carbon, the second one, and the third one, that is the last one, we will put like the triple bond. And then for the hydrogen, first we will put an hydrogen here at the end, and then in the first carbon we're going to write the 3 bonded, the 3 single bonds between the hydrogens that are like this. And now we're going to, yes, here that is complete because we only have like 4 hydrogens, so now we have the 1, the 2, 3, and 4. This was very easy because there are a few carbons and few hydrogens, but for example if we have C4H6, we are going to do this 1, 2, 3, and at the end we're going to put the triple bond and then the hydrogen and the 3 bonded hydrogens to the first carbon. Now we have 1,